Unit 2 of AP Physics 1 is a continuation of the study of kinematics. So we began the unit by learning how to add vectors, since in this unit we were going to start dealing with describing motion that wasn't just in one dimension, so straight forward or straight backwards, but in multiple dimensions, including projectiles. So remember, we have the tail to tip method of drawing vectors, where if I have, like, say 3 different vectors, like one that's like this, one that's like this, and another that's like this, in order to figure out what the resultant vector is, I would first put them at tail to tip. So, and again, it does not matter the order. So there's vector 1, and then the second one I put at the tip of the last, and then this one, so we put them all sort of in a row, and then the resultant vector goes from where we started to where we ended up, right? Now we can pick vectors up and move them around in space as long as we do not change their length or their direction, and we should always get the same resultant force, or sorry, the same resultant vector and the same resultant angle. So to figure out the angle of the resultant and the length of the resultant, remember the steps are to find all x and y components of each individual vector. And then step 2 is to add all x's, which will be the x resultant. And then also to add all the y's, which is the y resultant. Okay, and make sure that we're taking into consideration what is positive or negative. And then the third is to figure out or use the Pythagorean theorem. Oh gosh, I'm not going to spell that right. Pythagorean. We'll guess. Okay, theorem to find the resultant and trig for the angle. All right, so let's say we were looking at this one. We would get some y. This would be my x resultant. And then I'd also have some y, which would be my y resultant. And so this right here, I would make this a right triangle. And I could, oops, sorry, I went a little bit off the screen. So this is my x resultant, this is my y resultant. And then I'd use Pythagorean theorem. So x resultant squared plus y resultant squared. Y resultant squared would give me the total resultant hypotenuse squared. And then to figure out the angle, I could do really any trig function, but I could do opposite over adjacent and then take tan to the -1, so is equal to yr over xr. Okay, so that's just a quick review of how to add vectors, right? And again, we'll be doing this in other videos. So then we began to apply our concepts from Unit 1 to the idea of projectiles. So remember, there are a few rules when we're figuring out projectile problems. Number 1, that the x and y components of a projectile are treated independently. Step 2, we say that there is no acceleration in the x direction unless there is some force acting upon it. Remember, we can kind of assume that air resistance is negligible and friction is negligible in most of our projectile type problems, unless it's noted some other way. And then the acceleration in the y direction most often is going to be -10 meters per second squared, because it is acceleration due to gravity. And then the third thing we have to remember about projectiles is that the time something's flying in the air horizontally is equivalent to the time that something is dropping also horizontally. Okay, so dropping vertically. All right, so when we have a horizontal projectile, this is the first example. For horizontal projectiles, that is going to be something that is launched straight off of the top of a building and flying. horizontally or off a table and flying horizontally until it hits the ground. And so when we do horizontal projectile problems, this is going to be first treated in the x direction like it's a dropping problem. Oh, sorry, in the y direction. Sorry. Like it's a dropping problem. Okay. And then in the x direction, it is going a constant velocity, so we use Vx equals dx over t. So when we have a dropping problem, remember that my initial velocity in the y direction is actually equivalent to 0. So the equation that we're going to use is d is equal to 1/2 at squared for the first part, and then Vx equals dx over t. All right, so here's my dx, and then this would be my velocity in the x direction. All right, this is my distance in the y direction. This would be y stuff. This is y stuff. This is x stuff. And the time is the same. So just depending on what information you're given, you may be told how fast it leaves and how far it goes, and then you can figure out the time, and then you can use that time in the dropping part of the problem to solve for y things, or we can use the y things to solve for time and then figure out how far or how fast something is going off the edge of a table. Okay, so again, horizontal projectiles, we separate into two parts. The y part, so the up and down part, we use d equals 1/2 at squared like a dropping problem. And then for the x component stuff, we know it's a constant velocity, so we use Vx equals dx over t. All right, then the next kind of projectile we have is the example of an angled projectile, so something that's shot at an angle from the ground or even up off the top of some raised elevation surface. And for these, the first step to an angled projectile problem is to find the x and y components of the initial velocity vector. Okay, so once we find the x and the y of each of those, then we completely ignore this. Okay, so remember to never use the hypotenuse of that right triangle in any equation, right? It is only used to solve, it is only used with the trig to figure out what our velocity in the x is and then what our initial velocity in the y is, all right? Then we move on and we treat it like it is a throwing a ball up in the air problem, right? So in the last video, we said, okay, when you throw something up in the air, remember some things. The velocity here is equal to 0. The time up is equal to the time down. We know acceleration is equal to -10. So if we're going to use our y stuff, we're going to use d equals v initial y, and again this would be y, t plus 1/2 a, and we'll put a little y t squared there, or we might be using vf, y squared equals v initial y squared plus 2ad, or v final minus v initial all over t equal a. One of these equations just based on whatever parameters of the problem we're given. Right? We might be asked how high it is at its peak. We might be asked how much time it flies through the air total, right? So you just have to be like situationally aware of what is, what you're being asked. Are you asked the displacement when the total time has passed? Are you asked the displacement when half the time has passed? Are you asked the displacement when the velocity in the y direction is 0? All right, so there's all sorts of different things that you just have to ask yourself about the situation, right? But we will be using one of these constant acceleration equations when we're dealing with the initial or the y stuff. Then when we deal with the x stuff, again, we're moving at a constant velocity, so Vx is equal to dx over t. So we use our constant equation, or the constant velocity equation with no acceleration, right? So remember that this equation can only ever be used when the acceleration is 0 and not be used in one of these other cases, right? And in class and for review, we'll do some sample problems in order to sort of just give you some practice with these general ideas. But that wraps up pretty much everything we need to know to review through horizontal projectiles, vertical projectiles, and adding vectors.